Welcome students. This is again Ravi Shankar in order to teach you physics. So already in our last video we have studied about the problem number 1.6 at page number 13. Now the next problem, the example problem 1.7, available in the page number 15. Come on, go through the problem. If you are having your notebook, take your notebook and copy that problem. Consider the charge configuration shown in the figure. Calculate the electrical field at the point A. So you look at the diagram, you are having two charges, Q1 along the x-axis and Q2 along the y-axis, and you are having a point A. At that point A, you have to calculate the net electrical field. That is, due to Q1 you will get one electrical field, due to Q2 another electrical field. What is the net electrical field at that point A? One question. The second question is, at that point A, if an electron is placed, what is the acceleration produced by the electron? Let us calculate. So, what are the given quantities? We must know the mass of the electron, or it will be given in your problem. Mass of the electron, we can represent it as m suffix e, which is 9.1 into 10 to the power of minus 31 kilogram. Charge of an electron, represent as E, 1.6 into 10 to the power of minus 19 coulomb. And then from the diagram, I can state Q1 is equal to plus 1 microcoulomb, or it can be written as plus 10 power minus 6 coulomb. Q2 equal to again plus 1 microcoulomb, or I can write it out as plus 10 power minus 6 coulomb. The distance from Q1 to A, that I have written it as R1A, which is 2 millimeter. In SI unit, it is 2 into 10 to the power of minus 3 meter. Then the distance from the charge Q2 to A, represented as R2A, which is again 2 millimeter, and I have written it as 2 into 10 to the power of minus 3 meter. Let us get into the solution. So, in order to study the solution, first of all, let us consider how you can able to solve it out. See, I will be drawing the diagram again. So, solution. Again, I am drawing the same diagram. Here it is x-axis. Here it is y-axis, and this is the origin O. Here you are having the charge Q1. Here I am considering the charge Q2. At the intersecting point, we are considering the position, this point as A. Now, at this point A, let us calculate the distance. This distance R1A, and this distance it is R2A. Now, due to this Q1, you will get an electrical field here. Let it be E1. It is acting away from the positive charge. Similarly, from Q2, you can get another electrical field at A. Since Q2 is also positive charge, you can able to get the direction of the electrical field E2 along the positive x-axis. I am considering the positive x-axis as I cap and positive y-axis as j cap. Now, at this point A, you are having two electrical fields. What is the net electrical field? So, how to calculate net electrical field? Net electrical field is equal to vector sum of E1 and E2. Vector sum of E1 and E2. How? This is according to superposition principle. According to superposition principle. because at point A you are having two electrical fields and net electrical field. Let us consider it as EA vector. If EA vector is the net electrical field, then I can write it out as first E1 vector plus second one. We have to write it out as E2 vector. How I can simplify this? EA vector is equal to, what is E1? E1 vector is electrical field at this point A due to Q1. So the formula is 1 by 4 pi epsilon 0 Q1 by R 1A the whole square into R1A cap, or instead of this I can write it out as J cap, plus again E2 1 divided by 4 pi epsilon 0 Q2 divided by R2A the whole square multiplied it with R2A cap. So since this direction can be written like this, I can write like this: EA vector equal to 1 by 4 pi epsilon 0 Q1 by R1A the whole square into, this E1 is along the positive y-axis, so J cap, plus again 1 divided by 4 pi epsilon 0 into Q2 divided by R2A the whole square into R, instead of R2A I can substitute this as I cap because it is along the positive y-axis, positive x-axis. This is considered to be, I can write it out as what? I can write it out as I cap. See? So this one I am considering as I cap. This is I cap. Now we have calculated the value for E1 and E2. Now let us substitute it and get the answer. So what is this EA vector then? EA vector is equal to, instead of this 1 by 4 pi epsilon 0, 9 into 10 to the power of 9 multiplied it with Q1 10 power minus 6 divided by R1 square 2 into 10 to the power of minus 3 the whole square J cap, plus similarly 1 by 4 pi epsilon 0, again it is 9 into 10 to the power of 9 into here 10 power minus 6 divided by 2 into 10 power minus 3 the whole square into I cap. See, on simplifying I can write A vector equal to 9 taken as a common multiplied it with, see, 10 power 3, 10 because 10 power 9, 10 power minus 6, 10 power 3. Then in the denominator 4 into 10 power minus 6. Then it is again taken to the numerator. Now let us write one more step. It is 10 power 3 divided by 4 into 10 power minus 6 J cap, plus again 9 into 10 to the power of 3 divided by 4 into 10 power minus 6 into I cap. Now again you simplify. Let us write the next step. On simplification we can write it out as EA vector equal to 9 divided by 4, and this 10 power minus 6 taken to the numerator, it is 10 power 9. In both the factors, let us take this as common, so the remaining J cap plus I cap. Clear? On simplifying this, you can able to get the answer as 2.5, isn't it? 2.25 into 10 to the power of 9 multiplied it with I cap plus J cap. See, this gives both in magnitude and direction. So this we can state the unit also, Newton per Coulomb, and this expression or this gives the resultant electrical field at A in magnitude and direction. Clear? Okay. Now, how to calculate the magnitude first of all? If you want to calculate the magnitude, let us write or let us consider the diagram again. See, at this point A, along this direction you are having E1 and along this direction you are having E2. In between the two vectors you are having 90 degree. You might have studied about the parallelogram law of vectors, where the resultant vector can be calculated using the formula R is equal to root of A square plus B square plus 2AB cos theta. You might have studied this in your 11th standard. So here the resultant is EA vector, or the resultant magnitude is EA, modulus of EA vector, square root of, instead of A, one of the vector is E1, instead of B, another vector is E2. So I can substitute as E1 square plus E2 square plus 2E1 E2 cos 90. Since cos 90 is 0, this term tends to become 0. So modulus of EA vector is equal to magnitude of EA vector, which is equal to root of E1 square plus E2 square. So how to get the resultant now? You can see root of, what is E1 square? We have calculated as 2.25 into 10 to the power of 9. There you will be having j cap. Here we just need of the magnitude, so I am not concluding the magnitude, plus E2, again the same value, 2.25 into 10 to the power of 9 the whole square. So we have calculated the value of E1 and E2 substituted. Now simplify. How to simplify? See, when you are taking 2.25 into 10 power 9, out of the square root is common, you will be getting root of 1 plus 1. So magnitude of EA vector is 2.25 into 10 to the power of 9 into root 2 Newton per watt, Newton per Coulomb. This is what we are calling it out as the magnitude of EA vector. Then, what is the direction then? After calculating this magnitude, let us go for the direction. So, how to calculate the direction of the electrical field? See, direction of electrical field can be calculated using the formula the EA vector divided by its magnitude. Vector divided by its magnitude will be giving you the unit vector or the resultant. So what is the value of EA? What is the value of EA vector means 2.25 into 10 to the power of 9 multiplied with I cap plus j cap whole divided by the magnitude. Here you are having the magnitude is 2.25 into 10 to the power of 9 into root 2. On simplifying, you can get these two values cancel. Therefore, the direction is given by I cap plus j cap divided by root 2, which is the unit vector along OA, which is the unit vector acting along OA. What is that OA? See, while we are drawing the diagram, we are represented like this. Here it is O, and here you are having A, here you are having Q2, here Q1. So E1 is acting along this direction, E2 along this direction. Now the resultant, according to parallelogram law of vectors, it is acting along the line joining the diagonal of the parallelogram. So it is along what direction? Away from O. So it is taken as OA. This is the first part. So two concepts we have represented. One is EA. It's okay. One is we have calculated EA vector, that is 2.25 into 10 to the power of 9 I cap plus j cap Newton per coulomb, in both in magnitude and direction. Magnitude of EA vector, that is EA alone, which was given to be 2.25 into root 2 into 10 to the power of 9 Newton per coulomb, and the direction given by direction is I cap plus j cap divided by root 2, that is unit vector along OA. Okay. Now the second part of this problem. See, it was given that an electron is placed in the position A, or you can say at A. What is the acceleration? What is the acceleration? Let us calculate. So how to calculate this? See, again, let us consider the diagram. So in this diagram, here you are having Q1, here you are having Q2, and this is the point A, and the net electric, see, this is along this direction you will get E2, along this direction you will get E1, and the net electrical field is along this direction, called to be EA. Now at this point A, you are having an electron with a negative charge. What is the acceleration? See, we know that electrical field E vector is equal to F vector divided by Q. Therefore, the force F vector on the electron is equal to E vector along the direction at A. So EA vector into Q. Q, I am writing it as the charge of the electron. So I am taking it like this. EA vector multiplied it with E. Now you substitute and simplify. Before that, this force can be written as mass into acceleration of the electron, which will be equal to electrical field at A multiplied it with the charge of the electron. Now you substitute and get the answer for acceleration of the electron. AE vector is equal to EA vector divided by m into charge of the electron. Now what is this EA vector? EA vector is 2.25 into 10 to the power of 9 multiplied it with I cap plus j cap, again multiplied it with e, that is minus of 1.6 into 10 power minus 19 divided by, what is the mass, 9.1 into 10 power minus 31. So how to get the answer now? Simplify. You see, acceleration of the electron is equal to, I can take like this, 2.25 into 10 power 9 multiplied it with, I am taking this negative sign before or prior, so minus of, taking it as a bracket, 1.6 into 10 to the power of minus 19 whole divided by 9.1 into 10 power minus 31 multiplied it with I cap plus j cap. Now what will be the answer for this simplification is acceleration on the electron is equal to minus of, on simplifying this you can able to get 3.95. You try to do the simplification and get the answer into 10 to the power of 20 multiplied it with I cap plus j cap. See, now it was given the direction, you see, this gives you the magnitude. Direction, you see, minus of I cap plus j cap. So it is acting, since the direction is represented as minus of I cap plus j cap, the acceleration is acting, the acceleration on the electron is acting in a direction, opposite to the net electrical field A vector. This is what we are considering about the direction of magnitude and the direction of the electron. That's all. So go through the problem again, and for all these values I have not simplified here. You try to simplify by getting the logarithms. See, you write log for each and every quantity and simplify. That will be easier for you.